Okay, this is the P1 paper from October 2021. It's question number 2. As you can see by looking at this, this is a differentiation question. It's going to lead on to a quadratic when we actually get started with it. Let's have a look at it. We have a curve that has the equation y is equal to 3x to the 5 plus 4x cubed minus x plus 5. So straight away that's a little bit unusual because we've got to the power of 5, which we don't very often have. And it says points P and Q lie on the curve and the gradient of the curve at these 2 points is equal to 2. Yeah, that's quite possible, isn't it? We could have a situation, I don't know, something like that, where you've got a gradient equals 2 there and then another gradient equals 2 there. So that's no problem to me. I'm going to have 2 points where the gradient is equal to 2. Find the x coordinates. All right, so first of all, we only need to find the x coordinates, so it shouldn't take me too long to do it. But what I've got to do then, my game plan is differentiate. That will give me my gradient function. And if the gradient is equal to 2, then my differential, that gradient function, is going to be equal to 2. Get an equation, solve it, hopefully, and then we'll get our answers. So let's concentrate on doing the dy by dx bit properly. So differentiating, multiply by the power, take 1 off the power. It's going to give me that. Multiply by the power, take 1 off the power. It's going to give me that. Keep going. X's just become numbers and constants like 5 just disappear. So that's the differential. And then they've said gradient's equal to 2. So if the gradient is equal to 2, then that's equal to 2. So 15x to the 4 plus 12x squared minus 1 equals 2. And I want to at least make this everything equals to 0. So rearrange it like we would if we were doing a quadratic. So I'll just take the 2 over to the other side. I'm going to get 15x to the 4 plus 12x squared minus 3 equals 0. And then I would say to my students, what sort of equation have we got here? We've got a quadratic. I know it doesn't look like a quadratic, but all we need to do is make a simple substitution and say, let y equals x squared, and then I'll reverse that in a minute. But if y is equal to x squared, then 15x to the 4 is 15x squared squared. So it's 15y squared plus 12y squared, sorry, so 12x squared, which is 12y, minus 3 equals 0. Now, another thing that I would expect my students and expect you guys to see is they often do this business where we can just, before I try and factorize this, divide by a common factor here. 3 goes into everything. So if 3 goes into everything, I can completely divide there and get that equals 0. Once I've done that then, now I should be able to factorize this. I never spend any time on these videos talking about quadratic factorization. You can do that in a different video. If I'm going to factorize this, it factorizes to 5y minus 1 and y plus 1. So solving that is going to give me 5y minus 1 equals 0 or y plus 1 equals 0. That gives me y equals a fifth. And that gives me y equals minus 1. So now we're at the stage where we can reverse this and say, okay, if that's true, well then x squared equals a fifth or x squared equals minus 1. Well, I'm quite relieved to see that side there because I only think there's going to be 2 solutions to this, and immediately I don't get any solutions from x squared equals minus 1. Make sure you say it, don't just ignore it. There are no solutions there. Okay, that's an invalid situation. So that now gives me x squared equals a fifth, which means x is going to be equal to plus or minus 1 over root 5, which I would then tidy up, because I don't want the surd on the bottom, to plus or minus root 5 over 5. Okay, we don't have surds on the bottom. I've done that really quickly because I would expect you to know that if we just times top and bottom by root 5 there, we get root 5 all over 5. I don't even put that bit in. This is my final answer. Going back and just checking, it did just say find the x coordinates. Okay, and I only wanted the 2 points P and Q, and those are the x values, x coordinates of those points. So hopefully that makes sense.